In this video, we will create an HDA with the ability to create multiple curves with it, and these curves we will be able to draw along the geometry thanks to the viewer state. So there's gonna be a little bit of everything in this video. So the setup is something like this. We're using a couple of multi-parameter blocks that's going to create the points, and then we're going to create the curves from it, and then we're going to wrap it all around in a Python viewer state. And once we enter it, let's clear them out and let's take a look at it. Let's say if we want to add some points, and these points that we are adding are basically created along the geometry like that. And if we are not along geometry, it's going to create them on our construction plane. And if we want a new curve, we're going to set up our hotkey so that when we press it, we will get another curve and we can draw it inside the same HDA another curve like that. And if we want another one, we can draw another one. Let's get started by creating a subnetwork and creating a digital asset. So let's create a digital asset. What I'm going to do is actually, instead of saving to the file on disk, I'm actually going to save it inside my heap file. So just write inside embedded if you don't want your HDA in just to work within as an HDA only within this heap file. And the name and the label doesn't really matter, so I'm just going to press accept, since we are going to just take a look at everything around it. And if you want to create your own digital asset, you can do that. So inside here we have automatically output nodes, so let's put in for each loop, which is going to be for each number. Let's connect it inside here. And what we want to do is, first of all, let's worry about the, let's go to like properties and actually go to the basics, and minimum inputs should be, since later we're going to work about with collision. So let's actually connect our box to this one. So right now it doesn't really do anything, but once we start implementing our collision, it's still going to need our collision geometry, so that's fine. But right now let's just focus on getting our parameters, and so that we can manually change them and we have multiple curves, and then worry about the viewer state implementation. So we did this for each loop. It's pretty simple. Let's add a wrangle node. So I'm going to connect it inside here. So this wrangle is going to now be run however many iterations we run this. We could use the add node, which is basically just adds a point. But since it's so basic function, you can actually just use a wrangle for it. So, and in this wrangle we just want to add point, and so we want to connect it to the 0, and then we need the position for it. So just create a spare parameter channel, a vector channel, which is going to be pt post, something like that, and that should be it. And now we have created our point, and now we have, if you go back to at the very end of our for each loop, we have now 10 points at exactly the same place. And now let's go to the type properties for this HDA, and let's actually add some parameters. So first of all, we want to multi-parameter this pt position vector parameter we created. So first of all, for that we have to get the box. Let's call it so this is going to control how many points we actually copy. So let's call it a point count, and also let's copy the same as the label so we can easily see. And let's just take out the underscores like that, so we can easily reference by looking at the parameters label. And that, what we want to do is make sure that it's a multi-parameter block, and we want to put it inside our pt position like that, then apply it. Now that we have gotten our reference inside here, we can actually clear out this inside here, because we're going to reference actually the detail attribute of our wrangle node inside here. So we're not going to directly reference on top of this one. So this is just basically so we can get the vector per channel, and it's basically the same name as this one inside here. So that's that. Let's accept it, and let's actually put down a wrangle node inside here. And now let me open up our wrangle nodes inside code editor, and let's create a detail attribute that's going to reference each one of these new parameters on top of our HDA. So let's do that by re-add, let's call it a PT position equals, it's pretty simple. So we want to CHV reference, and this channel vector reference expects us a string as for the location of our parameters. And since we want our dynamically reference the next loop parameter, all we have to do is use a sprintf function, which is basically the same as a printf. It's only, but in this case it doesn't print out on the console, but it returns a string, which is exactly what we need for our channel v reference. So inside dot slash to go on to our curve on top of our, so basically go one level up and reference the channel. So our channel starts with a PT position, and then for our dynamic element we have to give it a percentage sign, and I'm going to do with the G. So for the numbering it can be kind of confusing, but you can see that basically in printf there's not really specifically for the sprintf function anything. So basically it's basically saying that it's uses the same formatting as a printf, and I'm just going to use it as a percentage size G, which is the printed integer vector and all of that in a general form. So this is basically what our dynamic element, and we want to do dynamically reference our detail attribute, which is the, so let's go inside here, our detail attribute e value. So we could make it a variable, but the easiest way is just add e value. Actually I'm going to, since it's an integer, e at e value, like that. Then just close it down like that. And one last thing we have to do is actually make sure that this for each actually follows how many copies we have in this point. So right now it's actually references, let's say, a channel number e value 10. So basically it says PT position 10, and we don't have this channel. So just go ahead and copy this channel reference and paste it inside for each loop as an iteration count, like that. And this should set up our references. You can see automatically if you go to the wrangle, its PT positions now 3, 1, 1, 8, 1, 9 and 0, 0, which is actually the numbers of the very last loop that we have actually created. And what's nice about this being a attribute, we can easily reference it without writing inside manually references for each one of these channels. Just go ahead and right click on PT position, go to reference, scene data, select attribute wrangle 2, attributes, global. That's going to use see our PT position and accept it like that. And let's actually call it a point count, and you will see it's automatically going to still, we won't have to update it inside here. So that's very nice. And now let's go on top of our HTA. Let's change some of these values. So let's change it on a y-axis. Let's go to the z actually. You can see each point now we can move it around like that. And now actually let's actually add our curve. So for us to create our curve, let's put down a wrangle node outside our loop, since we want only one curve for each loop that we do. Now let's open it up. First of all, we're going to use an add prim function, which inside here we're going to use this create a primitive using a specified point specified in array of point numbers. So what we want to do is all of these points that we just created, we want to create an array of it, and then just by this one line function we will create our poly. We're going to create our polyline. So let's go ahead and create our array of points. So it's pretty simple. So let's create an int value of pt count. So we want, let's do it like that. Let's endpoint. So it's basically just the number of points that we have. And then we want to create an empty array. Point, let's call it the point array. That's going to be empty for now. We just want to initialize it. And then let's use the for each loop. And in this counter, we will use the pt count. Since we are just referencing one time, we could also just use this endpoints inside here, but whatever. Let's use it as a variable. And then we just want to use an append function, which is going to append the values to the array. So array is going to be our pt array, and then the value that we want to append is e, like that. And now we have our array of all of the points. And now let's use that prim add prim function outside our loop. Add prim, the type is going to be a polyline. And then remember it asks for our array of points. So pt array, like that. And that's it. You can see now we have our points. And I mean, for now it's not very intuitive because we have to use these controls, but once we get working with our Python state, it's actually going to be very intuitive to add points to it. And now for our multi-curves to work, let's create another for each loop, also for each number, and we want to wrap this inside this one. So what we want to do is, since you want to multiple curves, you want to definitely get this one and connect the top of it at the very beginning, and move this inside here, something like this, so that we can see what's happening here. So now let's go ahead on top of our HDA, let's go to the properties, and let's actually add another folder on top of this folder. So this is going to now mess up with our references, but that's alright. So let's go ahead and put inside it this one. Let's go to the, also make it a multi-parameter block, and let's call this one curve count. Copy, paste it, and curve count. Applied. So now we have multi-parameter within multi-parameter. So accept it. So this would look like something like this. So we add our curves, and then for each curve we add our points. And now we have to do a couple of modifications. So first of all, let's connect this for each counter to our wrangle nodes in the second input. Since we want to, basically for every one of the point references that we now create, it's important for us to know which curve it is and which point count it is, because if you take a look at it, right now every reference is basically 2_2, which 2 is let's actually do the very last one. So you can see there's a position 3, which means the curve count, and then is actually the point count, which is right now it's 8 inside here. So we have to make sure that this actually now references multi-parameter within multi-parameter. So that's why we connect our curve counter loop inside here. And what we're going to do is actually create a couple more attributes. So let's go ahead and open it up. So first of all, our point position is going to be a little bit different now. So we're still going to keep the %sign G, but we want to expand it with another one, %_, remember the underscore, and then we have to need another number. So that's basically also %sign, also G. So inside here, since now there's the 2 values, we have to give it also 2 values. So this value at e value is actually the point value, the current point value, which is going to be the last one, which is the 8. So we have to give before that we have to give it a loop count. So we can do it actually, we could create a variable inside here and reference the second input, but since this is running over details and we also want detail attribute from here, we can actually use the add op input. So that's going to be 1. Op input going to, since it's connected here, it's going to be 1. And then its name is going to be e value, and that's it. It's basically same as the referencing variable, only from the other nodes, something like this. So now this returns correct references, so this is correct, and now we actually want to fix our iteration amount. So we want our iterations to be dynamic, since we are now, so basically want to point count is going to actually go up. So the thing that is not dynamic is our curve count, and our curve count is now at the very end of the for each loop iteration. So copy this curve count and reference it inside iteration amount, like here. And now to get the correct point number for every loop that we do, we have to get our channel reference. So now the channel we want to get is actually the point count. You see the point count is basically just a point count with the index of the current curve that we run over. So the very last one is going to be 4 if you have curve count is 4. So that's why we connected this one to here. And let's create this reference. So let's go ahead and let's actually copy this and paste it, and let's get an integer value. Since it's going to be how many points you want, it's an integer. It's going to be an integer channel. Since now we want only one index, we can delete the second one. And we want to get the amount of curves it is. So this is the index is basically just the curve amount. So let's delete the if value, which is the point amount. We just want to leave the op input value from this loop, like that, and we want to also change the PT position, since it's not a PT position but it's a point count channel, like that. And let's call it PT count, like that. And now let's reference this PT count variable inside our for each loop inside it, this iteration. Reference scene data attributes global and PT count, like that. So let's add some count. Let's to the very loop. Let's add 4, and this should be 4. And you see it works. Let's take a look at actually the end result that we have actually created. So let's clear it all out. So let's say I want to one curve and we want 2 points to it. So now we have one. Let's add another one, 2 points. You can see now we have 2 curves, 2 primitives, like that. And we can add how many points you want. And basically this is the for each loop and next part done. And we want to work on now the Python state. For our Python state, let's go ahead and let's go to type properties, go to the interactive viewer states, and let's create a new viewer state. So you can fill these up, but I don't really gonna do it. So what I'm going to do is check the add point sample, which will set up our viewer state a little bit more closer to what we need. And that's it. So accept it. So apply it, accept, and now let's open it up in a editor, like that. So first of all, let's delete this comment, so we don't need it. First thing that we want to do is actually get our curve count and the point count at any given moment in our viewer state. So let's go ahead and reuse this already function that's already set up for us. And let's start by defining our curve count, because our point count is dependent of our curve count index. So you see that at the very last loop we have curve count, the channel name is point count, and the index of the curve count. So the curve count is the one that we have to get information from first. So just go ahead and copy this method and paste inside here, and let's reuse it. So we know that our curve count is actually not dynamic. Its channel reference is always going to be the same. So you can basically use the same setup as a point count inside here. And all you have to do is just rename the parameter to the curve count. And let's call it curve count. So this is good. And now for our point count, we have to get our current core count amount, so to set up our point count. So what we could do, well, we could do it in many ways. We could create a attribute inside at the initialization as an instance attribute, but we can also create this instance attribute by using the decorator add property for our core count. And also I'm going to do the same for our point count. So this is going to allow us to reference these functions as a self.core count and self.point count, just like inside here at the init. But this is just a little bit easier way for us to do it. So let's go ahead and fix this point count method. So first of all, we want to change the parameter name to the point count, and then we want to format it. Just press F before the quotes, and in the curly brackets you want to reference self dot core count. So you can see we are now able to, instead of giving it a method call as a self.core count and in a curly brackets and then in a brackets in 10 brackets, we can just basically give it a self.core count and it's going to reference this one. And the same goes with the point count. And now let's fix our start method. So first of all, the start method is going to basically get our current point count parameter and decrease it by 1. And in this example, there's a self.index attribute, which we do not actually need. So we can actually delete this one inside here, because all it does is actually, it's just gets, you can see that it just basically calls just a self.point count in the original code. But since we are using property, we can just call it self.point count, and that's it. We don't have to assign it to another attribute. So we can delete this one. And then this multi-parameter, so we want to parameter that we want to increase is the point count. And then in the curly brackets, we just have to self dot, remember to F, to format self dot core count, and that's it. And after that, we are just insert multi-parameter, which is the self dot basically the current value of this parameter, so which would be the self dot point count. So we are, this and this is being called inside here, and we are basically increasing it by 1. Show this one. So, and that's it. So this start is already looking good. This is good. So begin state and undo, and end state undo is just so we can undo everything we do between this call and this call, so we can undo it with the one Control Z. So basically, if we add 1 point, then we can undo it with the one click of the Control Z. So this all looks good. So all of this for now can stay. Let's go to the main part of it, which is the onMouseEvent. You can see it basically says if the left mouse button, all of this code is going to be ran, which is the self.start method, which we just added, we just modified, and then it's just sets the parameters of these PT positions. So first of all, we can delete this use PT because we are not using it. So this use PT is being referenced by the, so this code was kind of intended to use with the add node because there's an option for us to actually enable the point, which is called use PT. So since we are using a wrangle, we don't need it, so we can delete this one. And the only thing we want to do is actually just set these values. So we just want one parameter inside here. Let's set up our parm tuple parameter reference. So I'm going to use the Python 3 formatting. So I'm just going to delete this. So F, and then we have to, so it's a PT position. So remember, so first of all is the curve count. So PT position, curly brackets, self dot core count, then the underscore, and then the self. Remember to close the curly brackets. Then the self dot point count. And then we can, so we don't need this one, so this looks good. Then want to set it to the position. Right now we're not going to worry about the collision. We just want to make sure that this actually works. And this is device basically is the, and actually let's print out the self.log whenever we move the mouse. So let's go inside here, self.log, and let's log out the variable, the attribute that is self.pressed. Let's print it out and take a look at it when it's actually is active. So let's go ahead to our viewer state. Let's enter it. So you can see it's already working for us. I press button and we are adding the point, and we can move it around, and we are setting this position like that, and we are also printing out the value of the self.pressed. So basically it's only going to be true when I move the mouse and when I basically press it and move around my mouse when the left button is pressed. So that means that every time I let go of the mouse, all of these parameters reset. So let's take a look at it why it's actually resets. So when we press the left mouse button, this is going to be true, and this code inside this conditional is going to be ran. So if device is left, so self.start, we ran this, and then we set the parameter. So this self.start is just to increase the count, point count by 1. And it's only going to be ran if self.pressed is equals false. And by default, by init, it's always going to be false. So basically, if this is false, this run, and then it sets itself to true. So this is going to be true, and this is going to be ran only one time while we hold down the button. And it's going to only reset because of the finish method that we didn't change, but you can see that it basically sets itself back to the false when the left mouse button is not pressed. You can see if the mouse button is pressed, this goes, otherwise it goes self.finish. Now let's set our hotkey for us to actually increase our curve count so that we add new multi-parameter and we can create a new curve. So for that we have to use another method which is not onMouseEvent, because we want to run it only when we actually press key, which its name is dev onKeyEvent. That's going to be also basically the same parameters like that. Let's actually print out the self.log, the Quark dictionary that actually is going to give us. So let's leave it some room. Let's take a look at it. So let's go ahead, enter. Let's press some button. I'm going to press N. You'll see. So when I press the N, you can see there's a bunch of stuff that we can get. But the most interesting is making sure that this will be ran only when we are actually pressing the hotkey. And what I want to do is actually get our dictionary from our device. So it's going to be from UI_event.device. So let's get basically it's the same one. It's basically the same UI_event dictionary entries as in onMouseEvent, but since this is always run when we move around the mouse, but we want only run this part of the code only when we press the hotkey. So we basically have the same device right now as inside here, because it's basically the same dictionary entry as a UI inside MouseEvent, and also UI_event. Let's just get these two like that. And now what I want to do is trigger some of the code only when we press some hotkey. So let's say that if device dot it's called key string. So this is going to basically return the key string where it's actually, you can take a look at there's a key string, and it's basically returns the string of the key that we just pressed. So let's say I want to assign my hotkey to the N. So just if this is N, what I want to do is increase it by 1 our multi-parameter our curve count. So all we have to do is self.parm node.parm called core count, and then we want to just basically use the same as inside multi-parameter instance. Just go ahead inside here and paste inside here, and as a value of it, we want to basically just give it a self that curve count, basically the current amount of the curve count, like that. So let's take a look at how it works. So let's go ahead inside it, let's clear it out, let's press N. You can see we are now adding a new curve every time I press the N button. Before we finish up with the collision, let's actually add our curve count. So let's say I enter my your state and this curve count is 0, and I wanted to start adding points. You'll see it's not going to work. Let's automatically increase this by 1 so that we can immediately start adding points. So let's go to the curve count method, and let's start by, so right now it's basically eval as int. What we want to do is make sure that if this is smaller than 1, so let's say 0 or negative values, we want to set it to the 1 and return 1. So let's go ahead and do that. So first of all, let's go to the like this. So if multi-parameter eval int is, let's say, smaller than 1, then we want to set our multi-parameter dot set as 1, like that, and then we want to return also the value. And then since we set 1, we can just return 1. But else, but if this is not smaller than 1, we just want to return its value. So then we just want to return multi-parm dot eval as int, like that. Oh, also remember we have to return multi-parameter value. Remember we have to return it. So let's clear it out. Let's go ahead and enter it again. You see, now we are automatically getting. Let's press N, get new curve. Now this works very nice. Let's clear it out. Let's start again. You see, let's add from here. Okay, so this seems to be working now. Now let's set up our collision. So first of all, we probably, when we enter our viewer state, we want to see on where are we putting these points. So we could like basically just put it as a template and then look at this geometry and add these points. But we can also do it inside HDA as a toggle whether we see the guide geometry or not. So that should be done inside. So we have one input, it's going to be our collision geometry. Go inside here, and this is our reference to our box. Put down a switch, and in switch it's going to be input 1, and then we want to put down a null node, which is basically a nothing node that outputs nothing, and we want to switch between them. Let's call it a collision, and well, let's call it actually maybe a guide geo, and just copy it and go ahead inside type properties and press it on as a guide geometry applied. You'll see now when we are entering our viewer state, we will see this guide geometry, and we probably want to get actually create a toggle whether we want to see it or not. So go ahead in parameters, put down a toggle node. It's actually going to be it's not going to be a toggle, but it's probably going to be a button, and in button type it's going to be a toggle, like that. Let's see guide, copy like that. Now that we have our toggle, let's go ahead and reference it inside our switch node. So select this, just hover over this C guide and press on copy parameter. Go inside here on switch geo. In the select input, just press on paste relative reference, like that. And actually these are not in the correct order, so we shouldn't probably move them around, because one should with 1 we should see it, and with 0 we shouldn't see it. So like that. And now you see when we toggle it, we will see our guide geometry where we actually going to add our points, like that. For our intersection with geometry, we have to set up our collision geometry. So first of all, let's go ahead and add another instance attribute. Let's call it self dot collision. Let's right now it's going to be none, but let's go to the on enter, which means basically when we press enter, we are going to set this value, get the geometry of this node. So go ahead and self.collision equals self.node dot. So for us to get our geometry, we want to get our guide geometry node. So it's called basically self.node.node and then guide geometry, guide geo, and now we have our node reference, but what do we actually get the geometry of it? So dot geometry, and that's it. Now that we have our geometry, let's go to the mouse event. You'll see it's using this basically this the position that it gets is actually from the construction plane intersection. So basically this plane that it's inside here. So let's go ahead and let's say you want to move our construction plane a little bit up, and if I go inside my view state and I add some points, you can see we are adding points on this grid. And what I want to do is actually, let's go ahead and let's put it back to 0. So what I want to do is actually, if I am intersecting with this geometry, put points under my mouse cursor where it's intersecting. But if it's not intersecting, then I want to use my construction plane. And you'll notice that this SU is imported module from our viewer state packages. And this is basically just a module for us to, I have actually opened it up inside here. It's basically a bunch of classes that are set up for us easier working within a viewer state. And it is very nice for us to use this geometry intersector class that we are going to use. And there's a bunch of information that we can get, but what we are interested is inside whether it's intersecting and the position of the intersection, basically these two. So let's go ahead and let's start working on this. So let's go ahead and go to the, let's call it geo intersect equals, so SU dot, so it's called geometry intersector, and then we have to give it the geometry that we want to intersect with. So that's going to be our collision, self.collision, and then the scene viewer, which is self.scene viewer. So now that we have our geo intersect, now what we want to do is set up our run the method of the intersect. So geo intersect dot, so it is the intersect method, and we have to give it the ray origin and ray direction, which is already given us inside here. So just copy these and paste them inside here like that. So now we are getting this info. So this is just the origin of our mouse cursor, and basically kind of like a ray that is shooting out of our mouse cursor onto a viewer state, and it basically reads the intersection of geometry. So now let's go ahead and override our position with the new position if the intersect is successful. So let's do it like this. So if geo intersect dot intersected, so basically this returns if true or false. So and this is just if this is true, then we want to set our position equals geo intersect dot position. So now basically if this is intersecting, we are overriding our position and setting it up, and this is going to read position from here and not from here. So let's go ahead and try it out. So let's go ahead and let's minimize it. Let's enter our viewer state again. So you can see we are adding our points, but right now we are colliding with our geometry, and if we are not intersecting, it is adding points to our work plane like that. So this is exactly what we wanted to do. Let's clear it out. We are basically drawing our curve along the geometry just like that, and if you're not, we are doing it on a work plane, construction plane. And let's do it. Let's enable our let's say we move up our construction plane, you can see we are adding here. So this is a very nice beginning for us to work more with this HDA setup. We might gonna get some snapping on it, and maybe something like dividing these edges so that we can add points exactly at the middle of it and at the point that we're creating at. So this is just the beginning, so definitely worth doing the initial setup for us to learn more about your states, and this is going to be kind of like our foundation for it. So and that's it for this video, I think. I hope you found something useful in it, and see you next time.